Welcome back, and we continue in our lesson. Today we are still going to go deeper into investigating the parabola. So at this stage I want us to understand certain properties of parabola. So we are going to take a look at what is called how to determine inverse. Today we need to understand how to determine inverses of a parabola. So first and foremost, let us just quickly talk about the nature of parabola one more time. We said parabola is of the form where f of x is given as y is given as equals to ax squared. So in this case, I'm going to use a monomial which just have a to investigate how do we get inverses of a parabola. So in this case, we shall have the two sides in this case. So let us have f of x being given as positive ax squared. So if this is our f of x and we want to find the inverse of that, let us have a real-time example where a is a real number. So let us have f of x in this case being given as our f of x. Let us start with our f of x being given as equals to 4x squared. This is our original, and we need to find the inverse of that. So rewriting this, it means y will be equals to 4x squared. We replace this f of x with y because that is our range. This is the domain. So y is equal to 4x squared. So since y is equal to 4x squared is given here, the process of finding an inverse is in two steps. Step number one, you must exchange position of x and y first. Let us exchange position of x and y, which means in the next step, what we're going to do now, we're going to see x being equals to 4y squared. Just exchanging, we have this. The next step after exchanging x and y, step number 2, is to make y our subject. Make y the subject. That is to, in other words, we're saying, let us solve for y. We need to leave y alone on one side. That is making y the subject. How do we do that? By solving for y, remove 4 first, which means divide both sides by 4. And we're going to have x over 4 is equals to our y squared. So since we removed 4 on both sides, we divide both sides by 4, both sides. Now we need to leave y independent. How do we do that? We're going to introduce a square root, which means a square root on the other side, x over 4 is equals to y. But we know a parabola will always have two sides, a positive side and a negative side. So which means finally we will have y. Conventionally, let's put this minus 1. This we can interpret and read this as y inverse. We don't read this as y exponent negative 1. This is y inverse. Our y inverse is equal to plus or minus. Then we have x divided by 4. We have determined the inverse of this function here. This is the inverse of this function. So y is equal to 4x squared. Its inverse can be written like this. Or we can simplify this to be plus or minus x plus or minus root x over 2. This is the very same way here. Because square root of 4 we know is 2, so square root stays on x, and here it remains 2 because now we know the square root of 4 is 2. So this is the inverse of this function here. So how do we then plot this inverse on a Cartesian plane? So let us continue with this. Now we know the process. This is the process of finding inverse. Exchange positions of x and y. That was step number 1. Step number 2, make this y to be subject. We've done that. We got the answer. So we now need to understand how do we then make or put this on a Cartesian plane. How do we draw both the inverse and the original on the same Cartesian plane? Let us do that. So we have our original. Our original is this one here. and our inverse is this one here. So let's have Cartesian plane. Here is our Cartesian plane. Cartesian plane x and y here. Our original is y is equal to 4x squared. So y is equal to 4x squared. We can draw our graph. It is central because when x is 0, y is 0. So our graph is central on the origin. It rises like this. Our graph rises like this. So now we know that it's a smile. It rises like this. It is a minimum point at this point where x is equal to 0. So this is our graph. The graph of y is equal to 4x squared. We have the graph. So from this one here, now how do we plot or how do we draw the inverse of this graph on the very same plot? Understand the dynamics. If we have a smile that looks upwards, this graph, and if we need to plot the inverse of this, the inverse is going to face to the right, which means our inverse will be in this format. This is our inverse. It rises like this. This is our inverse. We have drawn the graph of y inverse is equal to plus or minus square root of x over 4, or you can put it in this way. So this is the inverse, this is the original. We have our graphs. So let us understand, let us go deeper into understanding the concepts of that. Now we know that this is how we draw the original, this is how we draw the inverse on the same Cartesian plane. Let us try to understand now whether we need to understand, whether we need to restrict this or restrict that, because when we have this kind of graph, our inverse, it is not a function. The inverse of a parabola is not a function. So since the inverse is not a function, why is it not a function? Because when we draw a vertical line, the vertical line will pass at 2 points on our inverse. So reasons why this inverse is not a function is because it does not pass the vertical line test. So if it does not pass the vertical line test, then what are we going to do? We need to restrict either the domain or the range. So in this case, let us restrict it in 2 ways. So I'm going to wrap this for a moment, and if we are restricting, in this case, let's restrict the domain on the original. On the original, restricting the domain, if we restrict in this way where x is less than 0, where do we find x less than 0? Remember, x less than 0 is found from this point going this side. So this is x less than 0. So restricting this one on the original, it means we are trying to cancel this. Once this is cancelled, it means we have also restricted the range whereby y is less than 0 on the inverse. Let's repeat that. Restricting the domain x is equal to 0 on the original, which is y is equal to 4x squared. It helps to restrict the range on the inverse whereby y is less than 0. So restricting this, it restricts the other side, which means we are left with only y is bigger than 0. The graph is not on top, it's not below. So therefore, it makes this inverse to qualify to become a function, because once you draw any line along it, it passes the vertical line test. This is how we make the inverse to be a function. But remember, the original will always be a function all the time. But in order to make the inverse to be a function, you restrict it in 2 ways. When you restrict x is less than 0, you restrict this, you get this. But let's see on the other side. If we restrict, let's put it back. Here's our graph. Let us now change. and see if we are going to restrict on the other side where x is bigger than 0, what is going to happen? So let's see if we restrict the original, which is y is equal to 4x squared. Let's restrict what? X is bigger than 0. Restricting x is bigger than 0, it means on the original, we are cancelling this. We have restricted this. It's no longer there. Once that is done, you have also successfully restricted. You have successfully restricted y is bigger than 0 on the inverse. So that means we are going to also cancel this in this case, which means we are going to be left with this part for the inverse, this part for the original graph. So this is how we can make the inverse to be a function, because once you draw it normally, it is not a function because it doesn't pass vertical line test. Now it can pass vertical line test, which means drawing any line on it, any vertical line, that line can cross once. Therefore, it passes the vertical line test. So let's continue with our lesson and let's take a look at on these parabolas. How do we answer questions on determine the range, determine the domain of parabolas? So in this case, how to determine the domain and the range. Let us take a look at this. If A is positive and we have the graph that looks like this, and this is our graph whereby the turning point is here, and if the turning point is there at a point where it's negative 7, at a point where it's negative 7, it's negative 7 here at this point. So understand one thing. If we also have another one which is a smile, this is a Z in this case, and here's our Z in this case, the graph turns at a point where it's positive 8, where y is positive 8. So I guess maybe you're wondering, why are we concentrating on y value of the turning point? We are concentrating on that because of one and only reason, that when we are trying to get what is called the range, understand this statement, it is determined by y turning point. So it is determined by y value of the turning point all the time. Our range of a parabola is determined by y value turning point. So in this case, we are going to say, because the graph turns at y is equal to negative 7, and the graph is on top like this, the graph is a smile where a is positive, it means your range, in this case, write it as y is bigger than or equals to negative 7, and y is a member of real numbers. You write your range in this way. Now let's find the range here. Our range for the other graph, we can write it as y is less than or equals to 8, and y is a member of real numbers. This is how we determine the range. But take note that when you also want to determine the domain, we don't use y value for the turning point. What do we use then? So, if you're not interested in this, we want to see how to determine the domain. And what is the meaning of the words domain? Domain, it simply means the x values of the function that exist for that function. So take note, for both of them, be it a is positive, be it a is negative, the graphs are all going up. Sideways, they can exist at any point. So domain for this, it doesn't change. All the time it remains the same. That our domain here, our domain is x, is an element of negative infinity and to positive infinity all the time, because at any x value the graph exists. But the graph is only limited on the vertical part of it, that here it starts there and goes up, here it starts there and goes down. So this is what determines the range. This is what determines the range. But the domain, any value sideways can exist. So this is how we determine inverse, range, domain, and how to restrict domain, how to restrict domains, how to restrict ranges of the inverse, and therefore also of the original function of parabolas. Thank you so much for watching our videos, and make sure that on your way out you also take time to click subscription button and also like button and the notification button, so that as we make more content you also get time to be notified. Thank you so much for watching.